Hi everyone, I am Atchaya, Assistant Professor of Geology, A.D.M.COLLEGE for Women, NAGAPATTINAM. Today our topic is volcanic landforms. First of all, what is volcano? A volcano is a vent or fissures in the earth crust through which hot lava and volcanic gases are thrown out. Volcanic eruptions may be either explosive or quiet. In the earth's upper mantle, that is called asthenosphere. Under the crust is nearly molten magma originates at this depth. They migrate upwards, often along faults. In a volcano, the magma rises through a chimney-like openings called vent and reaches the surface as lava. At the surface, pressure is in the rising magma falls. As a result, dissolved gases are separated out. Such magma is called lava. Next, what is a magma and what are their characteristics? Here we know, since volcanic eruptions are caused by magma, a mixture of liquid rock crystals and dissolved gases, which is expelled out into the earth's surface. The three basic types of magma are there, that is called mafic or basaltic, intermediate or andesitic, and felsic or rhyolitic. First of all, mafic and basaltic, the silicon percentage is 45 to 55%, and this is high in magnesium, iron, and also low in potassium, and so on. Next, intermediate or andesite, the silicon percentage is 55 to 65%, and intermediate in magnesium and iron. And also next, felsic or rhyolitic, silicon percentage is 65 to 75% and low in magnesium, iron, and high in potassium. Next, the gases. At the depth in the yearly, all magmas contain gases. That gases gives magma their explosive character because the gas expands as pressure is reduced. Mostly H2O with some CO2 and minor amounts of sulfur, Cl and F. Next, felsic magmas usually have higher gas contents than mafic magmas. I repeated, felsic magmas usually have higher gas contents than mafic magmas. Next, temperature of the magma. In example, mafic or basaltic, the magma's ranges between of temperature 1000 degree to 1200 degree of Celsius. Next, intermediate andesitic 800 to 1000 degree Celsius. And last, felsic or rhyolitic type of magma which contain the temperature 650 to 800 degree Celsius. Next, the viscosity. The viscosity of magma is defined as follows. Viscosity is the resistance to flow, opposite of fluidity, depends on composition, temperature, and the gas content present in the magma. Next, higher SiO2 content of magma have higher viscosity than lower silicon content magmas. Next, the lower temperature magmas have higher viscosity than higher temperature magmas. Next, the types of volcanoes. Volcanoes commonly do not erupt continuously for long periods. Mostly, they slow intermittent activity depending on the variation in the frequency of their activity. Volcanoes are divided into three groups, that are active volcanoes, dormant volcanoes, and the final one is extinct volcanoes. The first one is active volcanoes. What is an active volcano? An active volcano is one which erupts very often. They mostly occur at the crustal plate boundaries. The volcanoes that occur along a great arc around the Pacific Ocean from Chile to the East Indies are example of active volcanoes. Next, the volcano type is dormant volcano. A dormant volcano is also the another name called sleeping volcano. Is somewhere between active and extinct. The dormant volcano is one that has not shown eruptive activity within the recorded history, but shows a geological evidence of activity within the geological recent past, because the lifetime of a volcano may be on the order of a million years. Dormant volcanoes can become active volcanoes all of sudden. These are the perhaps the most dangerous volcanoes, because people living in the vicinity of a dormant volcanoes may not understand the concept of geologic time, and there is no written record of any of the activity. The next volcano type is extinct volcanoes. An extinct volcano is a volcano that has not shown any historic activity, is usually deeply eroded, and shows no signs of recent activity. How old must a volcano be to be considered extinct depends on to a large degree on a past activity. The next is volcanic landforms. Volcanic landforms are divided into extrusive and intrusive landforms based on whether magma cools within the crust or above the crust. Rock formed by the cooling of magma within the crust are called plutonic rocks. Next, the rock formed by cooling of lava above the surface are called igneous rocks. Next, extrusive volcanic landform. Extrusive landforms are found from material thrown out to the surface during the volcanic activity. The materials thrown out including lava flows, pyroclastic debris, volcanic bombs, ash, dust and gases such as nitrogen compounds, sulfur compounds and minor amounts of chlorine, hydrogen and argon. Next, the conical vent and fissure vent are the types. Conical vent. A conical vent is a narrow, cylindrical and vent through the magma flows out violently. Conical vents are common in andesitic volcanism, that is composite of stratovolcanoes. A fissure vent, that is called volcanic fissure. It is a narrow, linear volcanoes vent through which lava erupts, usually without any explosive activity. The vent is often a few meters wide and maybe many kilometers long. Fissure vents are common in basaltic volcanism, that is shield type volcanoes. The next type of the landform is mid-ocean ridges. The mid-ocean ridges is what? The system of mid-ocean ridges stretched for more than 70,000 kilometers across all the ocean basins. The central portion of the mid-ocean ridges experience frequent eruptions. The lava is basaltic, that is less silica and hence less viscous, and causes the spreading of the sea floor. That is called mid-oceanic ridges. The next one of the type of landform is called compositic type volcanic landforms. That is, they are conical or central type volcanic landforms. Along with the andesitic lava, large quantities of pyroclastic material and ashes find their way to the surface. Andesitic lava along with the pyroclastic material accumulates in the vicinity of the vent openings, leading to the formations of a layers, and this makes the mound appears as a compositic volcano or a stratovolcano. This is divided into layers. The highest and most common volcanoes have compositic cones. Mount Stromboli, the lighthouse of the Mediterranean. I repeating, Mount Stromboli is the lighthouse of the Mediterranean. Mount Vesuvius, Mount Fuji are the examples of compositic type volcanic landforms. Next, this is the visual representation of a stratovolcano or compositive volcano. This is the cross section of the stratovolcano. This represents a plug dome, filling crater, flank center cone, and the sum of the dikes, teflon material eroded from volcanoes, and the intertubular lava flows and the pyroclastic material. or represent. Next, shield type volcanic landforms. This is the Hawaiian volcanoes are the most familiar examples of the shield type volcanic landforms. These volcanoes are the most mainly made up of basaltic lava. These volcanoes are not steep. They become explosive if somehow water gets into the vent, otherwise they are less explosive. This is a cross section of the sealed volcano, which is called a basaltic magma chamber. Thin 1 to 10 meter thickness of basaltic lava flows and the slope also present. This is the cross section. Next, fissure type flood basalt landforms. It is also called the lava plateaus. Sometimes a very thin magma escapes through the cracks and the fissures in the earth's surface and flows after intervals for a long time, spreading over a vast and finally producing a layer, undulations, wave-like flat surface. Example of the fissuring type flood basalt landforms are Siberian traps. Next one of the landform is called crater. Crater is an inverted cone-shaped vent through which a magma flows out. When the volcano is not active, the crater appears as a bowl-shaped depression. When the water from the rain or melted snow gets accumulation in a crater, it becomes a crater lake. Next one of the formation is called the caldera. In some volcanoes, the magma chamber below the surface may be emptied after volcanic eruptions. The volcanic material above the chamber collapses into the empty mag, and a chamber under the collapsed surface appears like a large cauldron-like hollow called a caldera. Next, when water from the rain or melted snow gets accumulated in the caldera, it becomes a caldera lake, as like crater lake. Next, one of the examples of caldera is called Lake Toba. It is the largest crater-like lake in the world. Next, the land formation is called cinder cone. What is a cinder cone? Cinder cone are the small volume cones consisting predominantly of ash and scoria that results from mildly explosive eruptions. They usually consist of basaltic to andesitic material. They are actually fall deposits that are built surrounding eruptive vent slopes of the cones are controlled by an angle of repose, that is angle of stable slope for loose unconsolidated material, and are usually between 25 to 35 degrees. Next, lava dome is also one of the examples of volcanic landforms. A lava dome is the mount-shaped protrusion resulting from the slow extrusion of viscous lava from a volcano. In lava domes, viscous magma piles up around the vent. The magma does not have enough gases or pressure to escape, although sometimes later after sufficient pressure builds up, it may be erupt explosively. The next one is pseudo-volcanic features. Is also one of the landforms of volcanic formation. Pseudo-volcanic features are certain topographic features that resemble volcanic forms but are not volcanic origin. They are including meteoritic crater, salt plugs, and mud volcanoes. Next, intrusive volcano rocks. That is, the intrusive rocks are those masses of igneous rocks which have been injected between the layers of the earth crust. These rocks can be further divided into two types, that is called concordant intrusive. Next one is discordant intrusives. Depending upon the arrangement of the invading country rock, the concordant igneous bodies are those which lie between rock beds, and the discordant igneous bodies are those which cut across the rock beds. Next, the sill concordant intrusive. A sill is a sheet-like igneous body which runs parallel to the bedding plane of the pre-existing strata. They may be horizontal, inclined or vertical depending upon the altitude of strata in which they are intruded. Next, sills vary in thickness from a few centimeters to a several hundred meters, but they always are thin. This is called sill concordant intrusive. Next one is laccolith. This comes under concordant type. These are large dome-shaped intrusive bodies connected by a pipe-like conduct from below. These are the intrusive counterparts of the exposed dome-like batholith. A laccolith may be 2 to 3 km in diameter and several hundred meters in thickness. In Karnataka plateau is spotted with the dome hills of granitic rocks. This is the visual representation of the laccolith. The next one is locolith. This is also comes under concordant. Locolith is a concordant intrusive having a lenticular shape and centrally sunken like a saucer or basin. The thickness is approximately 1/10 of the diameter. Thus, lacoliths are very large, much larger than laccoliths. The composition of locoliths is commonly basic. The next type is phacolith. Is also concordant type. A waving mass of intrusive rocks at times is found at the base of the synclines or the top of the anticline is folded igneous strata. Next one is dike. This comes under discordant type. When the lava makes its way through the cracks and the fissure developed in the land is solidifies almost perpendicular to the ground. It gets cooled in the same position to develop a wall-like structure. Such structure are called dikes. These are the most commonly found intrusive forms in the western Maharashtra areas. These are the considered the feeders for the eruption that will lead to the development of the Deccan traps. This is the example images of dike. The next one is volcanic neck. This also comes under discordant. Volcanic necks are the igneous masses which of ancient volcanoes, sills and dikes may depart out from the volcanic neck. Example of the volcanic neck comes under Dumgone volcanic neck of Scotland. Next one is batholith. This comes under discordant type. These are the large granitic rock bodies formed due to the solidification of hot magma inside the earth. They appear on the surface only after the denudation process remove the overlying material. Batholiths form the core of huge mountains. Next, what are the products of volcanic eruptions? Lava flows. When magma reaches the surface of the earth, it is called lava. Since it is a liquid, it flows downhill. In response to a gravity of a lava flows, different magma types behave different as lava flows depending on the temperature, viscosity and the gas present which is present in the lava. Next one is Pahahue flows. Basaltic lava flows with low viscosity start to cool when exposed to the low temperature of the atmosphere. This causes a surface skin to form. Although it is still very hot and behaves in a plastic fashion capable of deformation, such lava flows that initially have a smooth surface are called Pahahue flows. Next one is AA flows. Higher viscosity basaltic and andesitic lavas are also initially develop a smooth surface skin, but this is quickly broken up by follow flow of molten lava within and by gases that continue to escape from the lava. This creates a rough, clinkery surface that is characteristics of an A flow. Next one is lava tubes. Once the surface skin becomes solid, the lava can continue to flow beneath the earth's surface in lava tubes. The surface skin insulated the hot liquid lava from further cooling. When the eruption ends, liquid lava often drains, leaving an open cave. Next one is pillow lava. When lava erupts on the seafloor or other body of water, the surface skin forms rapidly, unlike with the Pahahue toes, inflates with the molten lava. Eventually, these inflated balloons of magma drop off and stack up like a pile of pillows and are called pillow lavas. Ancient pillow lavas are readily recognizable because of the shape, their glassy margins and the radial fractures that formed during cooling. Next one of the following is columnar jointing. When the thick basaltic or andesitic lava cool, they contract. The contraction results in the fracture, oftentimes results in a type of jointing called columnar jointing. The columns are usually hexagonal in shape. This often happens when lavas pool in depression or deep canyons. Next one is siliceous lava flows. High viscosity andesitic and rhyolitic lava flows, because they cannot flow very easily, form thick stubby flows and do not move far from the vent. Next one is lava domes or volcanic domes. Result from the extrusion of highly viscous, gas poor andesitic and rhyolitic lava. Since the viscosity is so high, the lava does not flow away from the vent, but instead piles up over the vent. Blocks of nearly solid lava breaks off the outer surface of the dome and rolls down the flanks to form a breccia around the margins of domes. Thank you.